What's up, guys? Good evening to you all. It's your bro, Richie here. Uh, tonight in this video, sorry. Tonight in this video is now part two. Part two on the Ford modular engine. Um, today in this video, we'll be talking to you all about the next version of the engine, which is now the turn of the legendary motor itself. The 5-liter Coyote. So this is gonna be pretty fun. So, so before I start, make sure you guys all like the video, subscribe, comment down below what you guys think, hit that notification bell, and hit the notification bell and hit all, so you learn it when I make brand new uploads. All right. So without any further ado, let's begin. So the 5-liter. So the 5-liter Coyote. Here we go. So the excuse me. So the 5-liter Coyote V8's first produced. So the 5-liter Coyote V8's first produced in 2010 for the 2011 model, for the 2011 model year. It was an evolutionary it was an evolutionary department, not department, sorry. It was an evolutionary development of Ford's modular V8, and is assembled in Ford's EEP Essex engine plant in Windsor, Ontario, Canada, using existing modular tooling. Ford engineers needed to design a V8 specifically for the Mustang GT that would compete with the GM 6.2 liter LS3 6.2 liter LS3 V8 motor used in the new Chevy Camaro and the new Chrysler derived 6.4 liter 6.4 liter Hemi V8 in the Dodge Charger, Challenger, Chrysler 300, and the Jeep Grand Cherokee. Since this motor replaced the already popular 4.6 and 5.4 liter modular V8s, this motor had to remain close to the same physical size of the outgoing 4.6 liter V8 and share other specifications with it, such as bore spacing, deck heights, bell housing, bolt pattern, such as bore spacing, deck height, bell housing, bore spacing, deck heights, bell housing, bolt pattern, etc., so on and so forth. In order for the motor to utilize existing modular product line tooling, the source of the modular modular designation for the engine family. The result was the 5-liter. The result was the 5-liter Coyote, which produced roughly the same amount. Which produced roughly the same amount of power, the same amount of power as its competitors, but with a much smaller display. But with a much but with a much smaller displacement. Um, it shares the 4.6 liter. Um, it shares the 4.6 liters. Um, um, 100 by 227 millimeter, 3.937, um, by by 8.937 inch bore spacing and deck height. So the 3.937 inch bore spacing and 8.937, so 3.937 inch bore spacing and 8.937 inch deck height. So the deck height is 5 inches bigger than the bore spacing. While both the bore diameter and stroke have increased to 92.2 millimeter. So 92.2 by 92.7 millimeters, 3.63 by 3.65 inches. So more spacing in deck lid were 100 by 227 millimeters, 3.937 by 8.937 inch. So while both bore diameter and stroke have been increased to 92.2 by 92.7 millimeters, 3.63 by 3.3 I can talk. 3.63 by 3.65. 3.63 by 3.65 inches, respectively. The motor also retains the 4.6 liters, 5.933 inch, 150.7 millimeter connecting rod length, which connecting rod length, which produces a 1.62 to 1, so 1.62 to 1 rod to stroke ratio. The firing order has been changed. So the firing order has been changed from that shared by all previous modular V8s. So it's wait. Kind of sounds like a mix of like a K20 and line 4. The one like the motor using S2000 that mixed with some V8. I don't know. Anyways, so anyways, so it shares the 4.6 liter. So it shares the 4.6 liters, 3.937 inch, 3.937 inch, 100 millimeter bore spacing and 8.937 inch 227 millimeter deck height, while bore diameter, both bore diameter and stroke had been increased to 92.2 by 92.7 millimeters, 3. 3.63 by 3.65 inches, respectively. The motor also retains the 4.6 liters, 5.933 inch, 150.7 millimeter connecting rod length, or con rod length for short, which produces a 1.62 to 1 rod to stroke ratio. Sorry about that, this is my charger. So 42% battery. Not too bad. Let's say 1.60 to 1 rod to stroke ratio. The firing order has been changed from that shared by all previous modular V8s. So it goes 1 3 so 1372 6548 to that of the Ford Flathead V8, which that run in at 1.15486372. Compression ratios 11 to 1. And despite having port fuel injection, as opposed to direct injection, the motor can still be run on 87 octane fuel. It's pretty good. So 87 octane gasoline, pretty good. The Coyote features all new 4-valve. So 4-valve. So the Coyote features all new 4-valve DOHC cylinder heads that have shifted the camshafts outboard. So outboard, which allowed for a compact roller finger follower setup with remote hydraulic valve remote hydraulic valve lash adjusters, and raised intake port geometry. intake port geometry. The results an intake port that allows the 4GT intake port by 4%, and the Yates D3. Yates D3. So, and the Yates D3 NASCAR. That's right, Yates D3 NASCAR. Yates D3 NASCAR. So NASCAR intake port up to 0.472 inch 12mm lift, which is the maximum lift of the Coyote's intake cams. The motor redlines 7,000 RPM. The Coyote's first implementation of its So the Coyote's Ford's first implementation of its CTA DIVCT cam torque actuated cam torque actuated twin independent variable cam timing in a wait. So the Coyote's Ford's first implementation of its CTA TIVCT cam torque actuated cam torque actuated twin independent variable cam timing in a V8 in a V8 which allows the PCM powertrain control module powertrain control module to both advance and retard both intake and exhaust cam timing independently of each other, providing improved power, fuel economy, and reduced emissions. So that's pretty cool. For those wondering what that was, it was a can of 7-Up. So yeah, the Coyote's Ford's first implementation of its CTA TIVCT, so cam torque actuated twin independent variable cam timing which like varies the intake valve timing by using the torsional energy to like rotate the camshaft. And mostly CTA variable timing is used mostly in like domestic cars like Mustangs, Camaros, Chargers, Challengers, you name it, it just uses it. It's a cam torque actuated, twin independent variable cam timing, and a V8 motor, which allows the PCM powertrain control module to both advance and retard both intake and exhaust cam timing independently of each other, providing improved power, fuel econ improved power, fuel economy, and reduced emissions. To strengthen the motor block enough to handle increased power output, webbing webbing's extensively used as reinforcement in the casting reinforcement in the casting rather than increasing the thickness of the walls. The intake plenums also situated low between the two cylinder banks to meet the high constraint to meet the height constraint. Thus, the alternator, traditionally placed low and center, was moved to the side of the motor. The Coyote made Ward's 10 best engines list for 2011, 2012, and 2018. Next is the Boss. Next is the Boss 302 Roadrunner variant. A higher. So next is the Boss 302. Next is the Boss. Next is the Boss 302. So next is the Boss 302. Next is the Boss 30. So next is the Boss 302. Um, so next is the Boss 302 Roadrunner variant. So a higher performance variant. So a higher performance variant of the Coyote, dubbed Roadrunner, um, internally by Fords, produced under the Boss 302 nickname used for the resurrected Boss 302 Mustang. So Boss 302 Mustang for the 2012 model year. The Boss 302 receives CNC ported heads cast in CNC ported headers cast in 356 so cast in 356 aluminum cast in 356 aluminum, providing additional airflow and strength, so both additional airflow and strength, and a higher lift exhaust camshaft profiles used. Valve train components were lightened as much as possible. So valve train components were lightened as much as possible, including the use of sodium. Valve train components were lightened as much as possible, including the use of sodium-filled exhaust valves, which strengthened powdered, both strengthened powdered metal rods and forged aluminum pistons were added. Piston cooling jets were also removed, which are standard in the 5-liter model. Exterior changes include a high output intake plenum, as opposed to the standard engine's low matted one. As opposed to the standard motor's low matted one, with shorter runs to improve high RPM power. Power is increased. Power is increased from 412 to 444 horsepower. So it went from a 2011 Mustang GT's power output to this actual Boss 302 2012's power output. Because back in 2011, the Mustang 5.0 GT made 412 horsepower, which is pretty good. Then a year later, Ford made the Boss 302 version of the Mustang with a lot more power, 444 horsepower. So that was an extra. So that was an extra 32 horsepower more. It's pretty good. So power has increased from 412 to 444 horse. So power is increased from 412 to 444 horsepower. So 412 to 444 horsepower. And so nearly 450 horsepower is pretty, which is pretty good. And torque unfortunately drops from 390. So from three torque un, and torque unfortunately drops from 390 to 380 pound-feet, 529 to 515 newton meters of torque due to the upgrades. So that was a 10 pound-feet, 14 newton meter decrease in torque configuration levels due to the upgrades. The boss's red lines increased to 7,500 RPM, but it's been verified. Uh, stable up to 8,400 RPM. So an extra 900 RPM is more than what it was supposed to have previously. Pretty good. Next is the Gen 3 update. For 2018, Ford made revisions to the Coyote equipped in the Mustang. For 2018, so we're on a Gen 3 update. For 2018, Ford made revisions to the Coyote equipped in the Mustang GT. Most notably the addition of high pressure direct injection, in addition to the existing port injection system, and an increase of the piston bore diameter from 92.2 to 93 millimeters, 3.63 to 3.66 inches. So it was 0.8. So that was a 0.8 millimeter, um, 0.03 inch increase uh, in the piston bore diameter. This increase in the bore size, so this increase in the bore size, resulting for the adoption of PWAT cylinder liner, so PWAT cylinder liner technology in place of the more uh, traditional sleeve in the motor block. More traditional sleeve in the block. So more traditional sleeve in the motor block brings total displacement up from 4.9 to 5 liters. So it's a 302 to 302 to 307. um, so for those who don't know what PWAT stands for, it stands for plasma wire arc transfer, uh, which is so basically it's known as PTWA, so plasma transferred wire arc, so wire arc thermal spraying. So, for those who don't know what that is, it's a thermal spraying process that deposits it's a thermal spraying process that deposits a coating on the internal surface of a cylindrical surface, or either that or external surface of any geometry. It's predominantly known for its use in coating the cylinder bores of an ICE, internal combustion engine, enabling the construction of aluminum motor blocks without the cast iron cylinder sleeves. The inventors of PTWA received the 2009 IPO National Inventor of the IP 2009 IPO National Inventor of the Year Award. This tech initially both patented and developed by FSI Flame Spray Industries, and subsequently improved upon by both Flame Spray and Ford. I'll just talk about most of it, like the process and applications. So a single conductive wire is used as a feedstock from the system. A supersonic plasma jet formed by a transferred arc between a non-consumable cathode and a wire both melts and atomizes the wire. A stream of air transports the atomized metal onto the substrate. So a stream of air transports the atomized metal on the substrate. So yeah, a stream of air transports the atomized metal onto the substrate. The particles flatten upon striking the surface of the substrate. So the particles flatten upon striking the surface of the substrate due to their due to their high kinetic energy, the particles rapidly solidify upon contact and can assume by both crystalline and amorphous phases. There's also the possibility of producing multi-layer coatings via stacked layers of particles, increasing wear resistance. All conductive wires up to and including 1.59, almost 1.6 millimeters, 0.0625 inches, can be used as feedstock material, including cord wires, cord wires, refractory metals, as well as like low melt materials, so refractory metals as well as low melt materials which don't melt as much, which are easily deposited. Then applications. So PTWA can be used to apply a coating to wear surfaces of either motor or gearbox components, serving as a plain bearing for the cylinder bores of hypoeutectic aluminum silicon alloy blocks. PTWA's main advantages over cast iron liners are both reduced. So PTWA's main advantages over cast iron liners are both reduced weight and cost. The thinner bore surface also allows for more compact bore spacing, and can potentially provide better heat transfer. Automotive motors that use PTWA include the 3.3 uh, included the VR38 DTT from the Nissan R35 GTR, a 3.8 liter twin turbocharged, VR38 DTT V6, and Ford's Coyote 5 liter V8s. The Caterpillar and Ford also use PTWA to remanufacture engines. So actually like bring back like the old engines back and all that. Anyways, so anyways, back to the Gen 3 update. So so for 2018, Ford made revisions to the Coyote, equipped for 2018. Ford, excuse me though, almost had a headache. Anyways, for 2018, Ford made revisions. Ford made revisions to the Coyote, equipped in the Mustang GT. Most notably the addition of HBDI, or high pressure direct injection. In addition, in addition to the existing port injection system, and an increase of the piston bore diameter from from 92.2 to 93 millimeters, 3.63 to 3.66 inches. So that was 0.8 millimeters. So 0.8 millimeters. What else? So 0.8 millimeters. 0.03 inches. This increase in the bore size resulting from the adoption of PWAT, or plasma wire arc transfer cylinder liner technology in place of the more traditional sleeve in the block, brings total displacement up from 4.9 to 5 liters. Other changes included what else they got? So there's a couple pieces that the car really had, well, that the motor was really equipped with. So other changes included Gen 3 specific camshafts, enlarged, so like bigger intake and exhaust valves, and increased, so bigger intake and exhaust valves, and an increased compression ratio of 12 to 1, or just 12.0 to 1. Well, 12 to 1, same thing, anyways. A revised intake manifold, and a 7500 RPM and a 7500 RPM red line in the Mustang. With these changes, the updated the updated 5 liter the updated 5 liter Coyotes the updated 5 liter Coyotes the updated 5 liter Coyotes rated so the updated 5 liter Coyotes rated by Ford at 460 horsepower. So 460 horsepower and 420 pound-feet, 570 newton meters of torque. The 2019-2020 both the 2019 and 2020 Bullet, and so both the 2019 and 20 both the 2019 and 2020 Bullet, and 2021-2023. So both the 2019 and both the 2019-2020 Bullet and 2021-2023 Mach 1 models of the Mustangs, so models of the Mustangs received an upgraded, so like up, so an upgraded version of the Coyote, so 5 liter Coyote V8 motor, rated at 480 horsepower, and so 480 horsepower. God, his headache kills me. I'm just gonna do it again. My God. Sorry about that. I apologize. God, forcing that just make my head hurt. Oh man. Alright, so for 2018, Ford made revisions to the Coyote equipped in the Mustang GT, most notably the addition of high pressure, direct injection in addition to the existing port injection system. So most notably the addition of high pressure direct injection in addition to the existing port injection system, and an increase of the piston bore diameter from 92.2 to 93 millimeters, 3.63 to 3.66 inches. So 3.63 to 3.66 inches. This increase in the bore size resulting from the adoption of so this increase in the bore size resulting from the adoption of PWAT, plasma wire arc transfer cylinder liner technology, in place of the more traditional sleeve in the block, brings total displacement up from 4.9 to 5 liters. Other changes included Gen 3 specific camshafts, enlarged intake and exhaust valves, an increased compression ratio of 12.0 to 1, or just 12 to 1, a revised intake manifold, and 7500 RPM red line in the Mustang. With these changes, the updated 5 liter Coyote V8 motors, rated by Ford at 460 horsepower and 420 pound-feet, 570 newton meters of torque, which is pretty good. Both the 2019 and 2020 Bullet and 2021-2023. So both the 2019-2020 Bullet and 2021-2023. So 2021-2020. excuse me, both the 2019-2020 2019-2020 bullet, so both the 2019-2020 bullet and 2021-2023 Mach 1 models of the Mustangs received, so both the 2019-2020 bullet and 2021-2023 Mach 1 models received uh, received an upgraded, so the upgraded version of the Coyote V8 motor rated at 480 horsepower, and so 480 horsepower and 420 pound 420 pound feet 420 pound feet, so 420 pound feet, 570 newton meters of torque. The 20 horsepower improvement, well, 20 horsepower increase was the 20 horsepower increase was so the 20 horsepower increase was due to both a intake manifold and 87 millimeter throttle body borrowed borrowed from the 5.2 liter Voodoo V8, as well as a recalibrated PCM, so powertrain control module. So they borrowed components from like the GT350, GT350R Mustangs and whatnot. Alright, next is the Gen 4 update. In 2023, for the last year's 2024 model year, the Mustang debuted with the Gen 4 of the Coyote. So the Gen 4 Coyote motor. It produces 400. It produces 400. It produces four. It produces 480 horsepower and 415 pound. It produces 400. It produces 480 horsepower and 415 pound. It produces 480 horsepower, so 480 horsepower and 415 pound feet and 415 pound feet. So in 415 pound feet, 500 so in 415 pound feet, 563 newton meters of torque. So 563 newton meters of torque, and in the GT trim level, 486 horsepower and 418, 560 and 418 pound feet, 567 newton meters with the active performance exhaust. So with the active performance exhaust, or APE option for short, and 500 horsepower, 500 horsepower, and 418 pound feet, 567 newton meters of torque. Well, 420 pound feet, 570 newton meters of torque, in the dark horse trim level. Updates included a revised 4-into-1 exhaust manifold, intake manifold intake manifold intake manifold with dual 80 millimeter throttle bodies. An intake manifold with dual with two, so twin 80 millimeter throttle bodies. The Dark Horse, meanwhile, also received revised camshafts. So both revised camshafts. So both revised camshafts and forged piston rods from the 5.2 liter Predator motor. Next is the F-150 variant, a torque biased variant of the Coyotes produced as an alternative to the EcoBoost V6 in the F-150. So the 3.5 liter is an alternative So a torque biased variant of the Coyote is produced as an alternative. Produced as an alternative to the 3.5 liter twin turbocharged EcoBoost V6 and the F-150 pickup truck and Ford GT 2017 model. So F-150 pickup truck and GT uh, supercar. So in both the Ford F-150 pickup truck and the Ford GT supercar. The F-150's 5-liter V8 receives a lower compression ratio of 10 point, so a lower compression ratio, lower compression ratio of 10.5 to 1, intake camshafts with less duration, cast iron exhaust manifolds, and revised cylinder. So cast iron exhaust manifolds and revised cylinder heads to improve cooling. The and revised cylinder heads to improve cooling. So revised cylinder heads to improve cooling. The intake manifold changed only in both color and height. These changes, these changes promote both low end and mid range promotes both low end and mid range both power and torque. So both low end and mid range low end and mid range both power and torque. The motor retains the Coyote's both forged steel crankshaft and crank pretty much, and piston cooling jets, but benefits piston cooling jets, but benefits from the addition of an external engine oil cooler similar to the Boss. So external motor oil cooler similar to the Boss 302s. The changes results in the motor's peak horsepower decreasing at 5,500 RPM to 360 horsepower, while at 4,250 RPM, uh, 50 RPM. So while at 4,250 RPMs, torques rated at 380 pound-feet, 520 Newton meters of torque at 4,250 RPMs. When the 2015 F-150 is revealed, Ford improved the induction system to pull air from above the grill under the hood, A.K.A. RAE, so rammer effect, as opposed to the as opposed to the fender intake out as opposed to the fender intake in, as opposed to the fender intake inlet the as opposed to the fender intake inlet that has been used for all Ford modular engines. The addition of RAE rammer effect pulled more cool air into the motor in favor for a power increase at 5,750 RPMs to 385 horsepower, the same as you get in a 2016 Porsche Cayman GT4 981. So at 5,750 RPMs, to 300 excuse me, to 385 horsepower, and at 3,850 RPMs, 387, almost 390 pound-feet, 525 Newton meters of torque. For 2018, numerous for 2018, numerous revisions were made to the 5.0 or 5-liter V8. Most notable, most notably the adoption of both a port and direct fuel injection system. So port and direct fuel injection system, as well as spray-on bore, as well as spray-on bore liner eliminating the need eliminating the need for conventional cast iron cylinder bore liners. Changes shares changes shared um, eliminating the need for conventional cast iron cylinder bore liners. Changes shared with the 2018 Mustang, and compression ratios increased to 12 to 1. Power increased to Power increased at 5,750 RPMs to 395 horsepower, while torques rated at 4,500 RPM at 400 pound-feet, 540 newton meters of torque. So at 4,500 RPM. Next one, this one is pretty interesting to me. The Miami variant. So this is gonna be pretty interesting. Let's do it. The Miami is a supercharged variant designed by FPV, a joint venture by both Ford Australia and Pro so by both Ford Australia and ProDrive. So FPV stands for Ford Performance Vehicles. While the Coyote is still in development, pre-production motors pre-production motors were shipped to Australia, where they're fitted with Australian developed superchargers. Australian developed superchargers. So superchargers. Both the motor blocks and crankshafts were common. So both the motor blocks and crankshafts were common with the U.S. Coyote motor, but the sump, rods, pistons, intake manifold, supercharger, exhaust manifolds, wire looming, and engine. So ECUs were both designed and manufactured in Australia. The U.S. Coyote motor had VVT, so variable valve timing, on all four cams, but the Australian ECU, but the Australian ECU had so, but the Australian ECU only had enough outputs to but the Australian ECU only had enough outputs to control two cams. So it's like I believe the intake and exhaust, I think. So had enough outputs to control two cams. So only the intake cams have VVTs, so variable valve timing. The supercharger uses Eaton rotors in a housing designed by Australian company Harrop HARR so HARR so Harrop so HARROP Engineering, the same company that provides superchargers. So the same company that provides superchargers to Rush Performance. Initial variants made 420 422 horsepower, 402 pound-feet, 500 402 pound-feet, 545 newton meters of torque, and 450 horse and 450 and 450 horsepower, 420 pound-feet, 570 newton meters of torque. Later versions made 463 horsepower, 471 horsepower, and ultimately 650 horsepower with the addition of an intercooler. The Miami variant however, sold in the Australian Ford Falcon Australian so sold in the Australian Ford Falcon based GT range, and the FGX XR8. The 650 horsepower version was sold in the Falcon FPV Holy Grail. Alright, last but not the very least, we got its application. So how many is there? Ooh, come on, this is gonna be the same as the last video. This is gonna take forever. So applications. The motor is gradually replacing both the 4.6 and 5. Both the 4.6 and 5.4 liter modular V8 units in all Ford vehicles. This is the first time that Ford's used the 5.0 designation since the pushrod. So this is the first time that Ford has used this is the first time that Ford's used the 5.0 designation since the pushrod 5.0s discontinued and replaced by the 4.6 liter modular unit in the mid 90s. So how many cars are there? So how many versions? So one, two. Around 20. So pretty much possibly the same as before. I don't know, but let's find out. Alright, so for the first one we got is obviously the Mustang GT. Before I tell you the first one, is need a drink. All right. So the first one we got is the Mustang GT. From 2011 to 2012, it made at 6,500 RPM, 412 horsepower, and at 4,250 RPMs, 390 pound-feet, 530 newton meters of torque. So at 4,250 RPMs. Number two, we got the Boss 3. Number two, we got the Boss 3. Number two, we got the Boss 302 Mustang from 2012 to 2013 at 7.5, so 7,500 RPM for power and 4,500 RPM for torque. It made 444. It made 444 horsepower and 380 pound-feet 515 newton meters of torque, and it was known as pretty much the Roadrunner, which means it had upgraded crankshaft, rods, pistons, headers, intake manifold, and camshafts. So upgraded. So upgraded crank, rods, pistons, heads, intake manifold, and camshafts. Red line increased to 7,500 RPM, so 7,500 RPM. Next is another Mustang GT, but from 2013 to 2014. So at 6,500 RPM, it made 420 horsepower, and at 4,250 RPMs, 390 pound-feet, 530 newton meters of torque, so around 10 pound-feet, 15 newton meters more than the Boss 302. So at 4,250 RPMs, and then it included removed piston oil squirters and recalibrated PCM powertrain control module. Next is another Mustang GT, but from another Mustang GT, but from 2015 2015 to 2017. That made at 6,500 RPM, 435 435 horsepower. So at 6,500 RPM, and at 4,250 RPMs, 400 pound-feet, 400 pound-feet, 400 pound-feet, 542 Newton meters of torque. So at 250 RPMs. So for the Gen 2, it had revised headers, valve train, and piston rods from the Boss 302 Mustang. But included with that, it had higher lift camshafts, intake manifold with CMC valves. Next, we got is another Mustang GT, but from 2018 to 2023. So that made the most amount of power, 460 horsepower, at 7,000 RPM, and at 4,600 RPM, 420 pound-feet, 570 Newton meters of torque, so at 4,600 RPM. So for the Gen 3, it included both direct and port fuel injection, increased compression ratio from 11 from so increased compression ratio from 11 to 1 to 12 to 1. Bore increase from 92.2 to 93 millimeters, 3.63 to 3.66 inches. So 0.8 millimeters, 0.03 inch increase. So revised headers and a 7,500 RPM and a 7,500 RPM red line. Next is the Mustang Bullet from 2019 to 2020. That made pretty much the same exact torque as the Mustang GT. Same RPM for power, same RPM for torque, but for the power output, the Bullet Mustang from the Mustang Bullet from 2019 to 2020 made an extra 20 horsepower increase from 460 to 480 horsepower. And that was thanks to a larger 87 millimeter throttle body, modified GT350 manifold, so modified GT350 manifold, and a modified GT350 manifold, and a cold air intake with a power control module recalibration system. Then we got the Mach 1 Mustang from 2021 to 2023, which pretty much has like exact same power and torque configurations with RPM levels as the Bullet, and had the same exact upgrades: throttle body, manifold, blah 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 blah. So pretty much the same as the Bullet Mustang. So both the Bullet 2019-2020 and Mach 1 2021-2023 Mustang both have the same exact performance. And next we got is the Mustang GT from 2024 and onwards, which made the same power as both the Bullet and Mach 1 Mustang, but at only 7,200 and actually 250 RPMs more. So 7,250 RPMs, it made 480 horsepower. So the Mustang GT from 2024 onwards, so 480 horsepower at 7,250 RPMs. But slightly less torque though. At 4,900 RPMs, it made 415 pound-feet, 563 Newton meters of torque at nearly 5,000 RPM. So this is a Gen 4 version, so we included higher lift camshafts, dual 80 millimeter throttle bodies, dual airbox air intake system, and it made 486 horsepower, so an extra 6 horsepower more. With the active exhaust system. Next is pretty much the latest Mustang ever, the Mustang Dark Horse from 2024 and onwards. So it made at 7,250 RPMs, it made 500 horsepower at 7,250 RPMs. It's pretty good. And at 4,900 at nearly 5,000 RPM, 418 pound-feet, 567 Newton meters of torque. So yeah, 4,900 RPM. So that included a rebalanced crankshaft, forged connecting rods from the 5.2-liter Predator V8 motor, and strengthened camshafts. Next is the Ford F-150. So we got four versions of them. So the first version is from 2011 to 2014. That made at 5,500 RPM, 360 horsepower, and at 4,250 RPMs, 380 pound-feet, 515 newton meters of torque. So at 4,250 RPMs. Then we got another F-150, but from 2015 to 2017, that made a little bit more power. This time at 5,750 RPMs, it made 385 horsepower, the same as a Cayman GT4, that ain't one Porsche. So 385 horsepower at 5,750 RPMs, and at 3,850 RPMs, it made 390 pound-feet, nearly 525 newton meters of torque. Then we got another F-150, but the 2018-2020 version. So next we got the 2018-2020 version of the F-150, which made an extra 10 horsepower more. So it made now 395 horsepower at 5,750 RPMs, 400 pound-feet, 542 newton meters of torque at 4,500 RPM. That included both direct injection and port fuel injection, increased compression, increased compression ratio from increased compression ratio from 10.5 to 1. So from 10.5 to 1 to 12 to 1. And bore was increased from 92.2 to 93 millimeters, 3.63 to 3.66 inches. So 3.63 to 3.66 inches. Sounds 0.8 millimeter, 0.03 inch increase there. Sounds for the Ford F-150. So the last F-150 we got is the 2021 and onwards versions, and that made the most amount of power at 6,000 RPM. It made 400 horsepower, dead on at 400 horsepower, pretty good. So dead on at 6,000 RPM, 400 horsepower, and at 4,250 RPMs, 410 pound-feet, 556, well, nearly 560 newton meters of torque. Next is the Ford Falcon GT from 2011 to 2024. So excuse me. Next is the Ford Falcon GT from 2011 to 2014, which made at 5,750 RPMs, 450 horsepower, and between 2,200 and 5,500, so 2,250 RPM, 420 pound-feet, 420 pound-feet, 570 newton meters of torque, and it was supercharged, by the way. Next we got is the XR8 version of the Ford Falcon. So the XR8 version, almost said RX8 for Mazda, but I think that's got nothing to do with it. Or RX7, that's also got nothing to do with it. So next is the XR8 version of the Ford Falcon from 2014 to 2016. So that made pretty much the same power output and torque level as the previous, as the GT version of it. And it was also supercharged. Apparently, the peak output was at 503 horsepower. So the same you get in an AMG GT and an Alfa Romeo Giulia Quadrifoglio. And this one with 503 horsepower, that is included with overboost. So overboost. Next is the FPV. So the FPV Ford Falcon GTF from 2014, that made at 5,750 RPMs, 471 horsepower. But however, apparently you can get this for an extra 71 horsepower more with overboost. and that brings up level to the same power output as a 2012 R35 GTR. That makes like 542 horsepower as well. With overboost, that's just crazy. So that was at 5,750 RPMs. That was just with overboost. And at between 2200 and 5500 RPMs. So 2200 and 5500 RPM. So 2200 and 5500 RPM. 420 pound-feet. 570 newton meters of torque. So pretty much it just makes the exact same torque as the 2014-2016 Falcon XR8, but the FPV Ford Falcon GTF from 2014 made a bit more power to it, actually like 20 or so horsepower more. Same RPM, so it made 471 horsepower. However, you can get it with 542 horsepower with overboost, and it was supercharged, by the way. Next is the TVR Griffith from 2020. So next is the TVR Griffith from 2020, and apparently, like, when I first saw this car in Forza Horizon 4 2018, it kind of looked a little bit like a Mark V Supra, apparently, but I don't know. It looks pretty interesting. Anyways, so we got next. So next we got is the TV. So next we got is the TVR Griffith. So TVR Griffith. So TVR Griffith Gen 2. So Gen 2, which apparently was a prototype in 2017 previously. So next is the TVR Griffith from 2020. That made 500 horsepower and 430 pound-feet, 583 newton meters of torque, and it was tuned by Cosworth. Next, we got is the Panas Esperante from 2014 to 2015. That made so 2014 to 2015. That made 450 horsepower. So 50 less than the TBR, but well, it's still fast. 450, 450 horsepower, and 420 pound-feet, 570 newton meters of torque. So 10 pound-feet, 13 newton meters less than the TBR, but still pretty damn quick. So pretty fast for a sports car like this. So 420 pound-feet, 570 newton meters of torque. Okay, the second to last one. So we got next one is the. I can't really see it from this distance. So next is the Puritalia, Puritalia Berlinetta from Puritalia Berlinetta from 2019 and onwards. It made 750 horsepower and 625 pound-feet. 850 newton meters of torque, and it was a hybrid with a 250 horsepower and 273 pound-feet, 370 newton meter Yasa. It's like saying NASA, but taking out the letter N and putting it and replacing it with a Y, and you get the YASA electric motor. So that was so before all that, it made around 535 horsepower. So 500. So around 535 horsepower, and and God, this equation is gonna take a while for me to do. around 352 pound-feet, presumably. So let's upgrade your new meters. I gotta figure this out. Around 478, presumably, new meters arc. I'm not so sure. Around 480, almost. So around 478 new meters of torque. That was before all this hybrid equipment just took it over. So hybrid with an extra 215 horsepower and 273 273 pound-feet, 370 newton meters of torque. Yasa electric motor. Last but certainly not the very least, we got is the Di Tommaso P72 from 2023 and onwards. It made 750 horsepower, the same as the Pure better than that, but with the most amount of torque, pretty much. So 750 horsepower and 664 pound-feet, 664 pound-feet, 664 pound-feet, so pound-feet, 900 newton meters of torque, and it was supercharged. So the Coyote is available. The Coyote is available. The Coyote is available as a crate motor. So the Coyote is available as a crate motor from FRPP, Ford Racing Performance Parts, complete with alternator, manifold, and wiring harness. And so alternator, manifold, and wiring. So alternator, manifold, and wiring harness. And standard 412 horsepower configuration. Last part, and I'll end it there. The Boss 302 is also available from from FRPP for a premium over the standard 5-liter V8. All right, so that's pretty much it. So for my next video will be about the 5-liter, not 5-liter, the 5.2-liter motor. Starting off with the first one is the Voodoo V8. So that's gonna be pretty cool. So it's not gonna be much anyway, but oh well, it'll be pretty cool. All right, so that'll be it. So if you guys like this video, like, subscribe, comment down below what you guys think. Hit the notification bell and hit all, so you learn when I make brand uploads. All right, so that'll be it. I gotta go. I'll see you guys in the next video. But until then, stay safe, have a great evening, and have a great day tomorrow morning. And I'll see you guys soon in the next video. So yeah, take care, folks. Stay out there, and I'll see you guys soon. Bye bye.